and welcome back to the Torras AI podcast. We are excited to have Jose Fernandez da Ponte with us today. Jose is the Senior Vice President and General Manager of Blockchain, Crypto, and Digital Currencies at PayPal. With over 2 decades of experience, including leadership roles at BBVA, McKinsey, and Hewlett-Packard, Jose brings a huge knowledge in finance, technology, and AI. Jose, thank you very much for being with us today.
Thank you, Jordi. So good to be here. Thank you for having me.
Absolutely. So, Jose, what do you do as Senior Vice President for Blockchain, Crypto, and Digital Currencies at PayPal? Sounds fascinating.
It is fascinating indeed. I have the luxury and the privilege of leading the work that PayPal does in digital currencies. I've been involved in payments for the last 20 years. As you were saying, I've been involved on blockchains for the last 10 or so. And I'm now leading the work that we do on the PayPal side, which is a dedicated team of about 300 people who we only do digital currencies. The idea there is that we believe that digital currencies have the potential to revolutionize payments and create, for the first time, at least in my lifetime, new payment rails. And we do everything that is in that gamut. We have the ability to buy and sell tokens, Bitcoin and the like in PayPal or Venmo. And we have also launched our own stablecoin. There is a PayPal USD stablecoin that is an Ethereum token for those in your audience who are crypto nerds. That has been circulating around, and we look at it as tokenized PayPal balance. It's fascinating. There are a lot of new primitives in the technology, not dissimilar to AI. There's a lot of primitives in blockchains that truly will reshape the way we do payments.
Wow, that's amazing. You are absolutely fortunate to be there. That's absolutely amazing. So when we go to the financial sector and we think of AI, right? So AI and predictive models have been used in the sector for decades now. So would you let us know a glimpse of how all this has been done in the past?
Well, we talk a lot about generative AI these days, and generative AI is obviously is the deployment of AI models to generate new data and new content. Most of the activity in financial services historically has been on the other side of AI, on predictive AI, not generative AI. Predictive AI is basically the use of massive amounts of data and algorithms to make predictions or generate new patterns of data. Those are algorithms that originated, many of them, in the 80s and 90s, but only about probably 15 to 20 years ago became of practical use in finance, because before we just didn't have the ability to treat data or the massive amounts of metadata that are needed. So historically, a lot of that evolve around risk management first, so avoiding losses more than making additional profits, which in finance usually has to do with 2 things. One of them is fraud management. Fraud management meaning people who will get access to your payment credentials or your credit card number, or do an account takeover on your bank account, or simulate that I am Jordi and I'm going to use your credit card number to buy stuff online. That is one side of the equation. Mm-hmm. The other traditionally has been risk underwriting. So banks obviously give loans. To give loans, you need to analyze the creditworthiness of the individual or the company that you're giving a loan to. And the very first models around loan underwriting using AI were done with logistic regressions way back then. And they have evolved quite a bit. I was lucky when I was working in banking. I was part of the team who did the first loan underwriting model in Spain that I know, that was using gradient boosting for doing underwriting for SMBs. So it's been a long way since logistic regressions to where we are now.
Wow.
And we will talk later. I'm sure that there will be a few comments or questions around issues with biases and scalability and explainability of those models.
Absolutely.
But at the very beginning, again, mostly risk management over the last 10 years or so, with improvements in data availability, but also with improvements in data engineering, the realm of applications has been so much wider than in the past. Think of, I work for PayPal, as we have been discussing. Think of PayPal from the point of view of graph theory, which is one of the ways in which we apply AI. Mm-hmm. PayPal has more than 400 million consumer accounts and more than 40 million merchant accounts. If you think about it in graph terms, you have a graph with almost 500 million nodes who are interacting all the time. And when there are intelligent actors, there are enemies who are intelligent actors and are acting all the time there. And from a pure sheer problem of computing, you cannot just handle a graph with 500 million nodes. So you need to do sampling, you need to do a number of things that were really difficult to do in the past. And from an AI perspective, the way that you sample those nodes and the way that you try to detect and supervise activity through unsupervised models, you need to try to find adversarial activity is a fascinating problem to explore.
Wow. So let me think about that. Let me what you just said about nodes and graphs, because when I'm using PayPal, I don't know, I want to pay something, I want to get some money, but I am a node, and the guy who I'm trying to pay is another node, and then there are 500 million all interconnected, having transactions which produce a huge amount of data. And now I see the vision is like, hey, how can we make sure that this traffic in this network is the one that is healthy, is secure, and that's a big network. So indeed, you guys need AI. That's amazing.
Think about it, because also having an intelligent adversary obviously complicates everything, right? So let's continue with your analogy. You're a node. I am another PayPal user. I am another node. You're sending me a peer-to-peer payment because we're splitting the bill for dinner or whatever. And that transaction is the edge between the two nodes.
Yep.
And if we are honest players, that's all you need to know. But what happens if somebody stole my phone? Or what happens if 3 nodes down the road, you can trace back that actually I am not Jose. You have set up a new account masquerading as myself. And so there is a moment in that graph in which you can find that there is a common node that is pretending to be 2 fictitious users moving money back and forth. So those are really complicated problems from a data handling activity. And again, the most fascinating aspect of it is that you're dealing with intelligent adversaries who are changing their patterns all the time. As you said, PayPal is obviously a payments company, but the other way in which you can think about it internally is that it's a cybersecurity company that happens to move money.
Absolutely. You call it intelligent adversaries. I call it bad guys. The guys who are trying to steal our money.
There are indeed bad actors. And in the overlap, and you're looking at that from a PayPal perspective, the beauty of the PayPal system is that it's a double-sided network, which is kind of payment jargon to say that you have both the buyer and the seller in the same network. Usually the way payments work, if you're doing a transaction with your credit card at Starbucks and you go buy a coffee and you swipe your credit card, the way that the payment industry works is there is on the one side the issuer, which is your bank, who gave you the credit card, and the issuer has information on you. And the other side is the acquirer, who's the point of sale terminal at Starbucks, who captures that transaction. And that is a different company. So the issuer, your bank has information on you, the acquirer has information on Starbucks, and there is some information that gets there, but it's not perfect. If you're interacting on a double-sided network like PayPal is, or American Express, for instance, it has the same thing, both the buyer and the seller are on the same network. So you have all information from both sides of the transaction. And that is what allows you to deploy those models in a much more effective way.
Wow, that's amazing. So back to the AI. So now AI is evolving at an incredible speed. For the last couple of years, that's been exponential. Some say, right? So how are these applications also evolving? And also, about bad actors. I'm assuming that they also have access to the same technology and they are using AI as well. So how is this kind of a almost technological war happening with the acceleration of AI?
Well, the fight against fraud between the good folks and the bad folks, as you were saying, the good actors and the bad actors, it's always an arms race. It's always evolving. There's going to be a breakthrough. And it's so even you see a geographical migration. You see a new fraud pattern that appears in one country, and then you can see that it's going to move across geographies, and you will start to see it popping up in other places. Even in my space, my professional space on the blockchain side, that gets even compounded, because then you're not inside of the PayPal universe or the American Express universe. You are interacting with permissionless blockchains where everybody can download a Bitcoin client and start moving funds around. So we actually, one of the things that my team did in the last year is a fantastic collaboration with the Turing Institute in the UK, the preeminent AI educational institution in the UK, where we were and with a company that does blockchain transaction monitoring and forensics, basically observing and deploying what is the activity that is going on in blockchains, where we did an academic article about how to identify the key actors in dark web marketplaces. When there is a crime ring that operates on a blockchain, and then they get dismantled by the police, how those nodes disappear and then emerge in a different part of it. If you're interested in data science and you're interested in AI, blockchains are actually a dream come true, because you can see all that information is immutable, it's in the ledger. You can see how transactions happen, and there is much more visibility that is actually in the traditional money and banking world.
Really, that's amazing. I never thought that blockchain and AI could actually benefit from each other. That's amazing.
And it's funny because you have it both ways. You have AI on blockchains, which is the case that I say is how do you use AI to analyze data on blockchains. And then you have blockchains on AI, because there are some problems that are specific for blockchains. And I know the podcast is about AI, but I can't stop talking about blockchains. If you think of a blockchain, basically you think of Ethereum, which is one of the large blockchains. It's a global computer. It's a virtual machine. Basically, it's a big computer in the cloud that you can program and write code. And that code becomes mandatory for people who are interacting with the code. And that is what is called a smart contract. There are a couple of very, very fundamental problems on blockchains that are getting addressed by AI. One of them is, who's going to do the audit of the smart contract? So imagine that I write a smart contract using Solidity, which is the language of the Ethereum blockchain, and I put it out there and people start to interact, and there are money who's getting locked in the contract. And I say, hey, I'm going to pay Jordi this amount when this oracle tells me that UPS delivered that good and is hands off and the smart contract is doing its thing. How do I know that the smart contract is well done and is being audited? In the last 10 years, it has been actually a quite manual process. It's been companies who go there and do audits of the smart contracts. Now you can start to deploy AI agents who will explore the code of the smart contract and try to figure out whether it's doing what it's supposed to do. The other aspect that is where they conflate is, as you know, there is a huge problem these days with training data and the provenance of training data. Part of that is copyright. Recently we have seen the debate on the media, less the debate, but news on OpenAI using Scarlett Johansson's voice without her permission and all those things. So you need a way in which you can track that the data that was used to train the models was used with permission, and also that the data is accurate. And one of the things that blockchains are really good at is at tracking provenance. That you can say that you can it's called a blockchain because there's a chain of transactions. So you can track that the data has been used and moved node to node from a party that gave permission. So it's a fascinating space in what is getting called now decentralized AI, which is probably startup jargon to get funding from VCs. But it's that combination of blockchains and artificial intelligence algorithms.
Well, decentralized AI running on a global virtual machine sounds as hot as you can imagine. That's amazing. As well as in the real world, the real contracts usually were managed by lawyers. They would read the contract and say, well, careful here and here because there's these clauses. But now contracts are going to be code, essentially. So who's going to read these codes is not a lawyer. Probably also engineers are humans. So AI can do that for you.
Okay, a smart contract is even a worse name than artificial intelligence. Artificial intelligence is not intelligence, but at least it is artificial.
Oh,
Smart contracts are not smart, and they are not contracts. You cannot take that to a court of law. It's basically self-executing code, but that has less of a ring to it.
That's amazing. Hey, could you let us know some example on some successful implementation of AI in finance?
There are many. As we said, it's very profusely used on loan underwriting. Part of what we said is how do you move from logistic regressions to more black box type of models, and that creates a really important issue, which is what is the trade-off between explaining power and explainability. So if you have something like a logistic regression for someone who has, you and I are both in the US now, somebody who has a relatively high credit score. Actually, the predictive power of a logistic regression model is pretty high. If you want to do, you can of course train deep learning models to do credit underwriting. The issue that you're going to have then is that you're getting better prediction power. It explains reality, makes better predictions of whether somebody's going to pay or not, but you lose explainability. And when you're working on a regulated environment, and that applies to finance, but I'm sure that it also applies to healthcare or energy or other regulated spaces, it is really important that you can comply with your regulatory obligations. And one of them in finance, in all the markets that I know in the world, is that you need to be able to prove that the decisions on loan underwriting are not discriminatory, that they are not biased against a specific population. So you need to be able to go to the regulator and explain, this is the way that my model makes a decision. And with a deep learning model, it's kind of problematic because it's a bit of a black box, and you don't really know how the weights are being changed in every moment and in every transaction. So you see a few things that are being successful there. One of them is the whole space about explainable AI. So how can you do that in a way in which you can at least identify which are the variables that are explaining most of the predictive power of the model. And there are others who are just trying to increase the performance of those types of models that are easier to explain. There is, for instance, a ton of work that is happening on what is called optimized decision trees, which is a decision tree is obviously very easy to explain. Say these are the branches of the trees, and that is how the model is making the resolution. So, and the issue that you have is that you don't know, finding the optimal decision tree is an NP-hard problem. There are not infinite, but an incredible number of possibilities in a decision tree.
Correct.
And just making sure that you are using the right one is really complicated. And there is a body of work mostly driven out of MIT who's trying to define a way in which basically deploying an enormous number of combinations of decision trees and then kind of collapsing, it's not really collapsing them, into finding what is the optimal one. Another very successful, or something that I've been very excited about, and where I did some work with my team in a prior company, has to do with how do you treat confidential data? How do you treat encrypted data? And that might be, for instance, imagine that credit scoring was a utility. And in the end, everybody benefits from having a credit score that uses information that you can take to bank A and bank B and try to get loans from both of them. While if there is no credit score, basically there's going to be, your bank is going to have more information from you about you than the other bank. So when you apply for a loan to both institutions, you're not gonna get very competitive offers because one offer was gonna have more information than the other. So it's in your best interest that it can be more competitive. But asking banks to combine the information or make the information available to train the models is obviously has a number of what is called personally identifiable information, has a number of constraints, but also there are competitive reasons not to share information among bases.
It's a competitive advantage at the end.
Indeed. So there is now one of the technologies that is being applied is called homomorphic encryption, which basically means that you can encrypt the data while preserving the structure of the data inside the database, and then you can deploy neural networks on top of the encrypted data. which is fascinating. It means that
Wow.
you can generate you can learn from the encrypted data without sharing the data within the parties.
Huh.
It is still relatively early stage, and it has some scalability issues. But you can do, even with the size that you have, in the end, for instance, for long underwriting, who's a decision that does not involve a zillion parameters, you can do enough with homomorphic encryption. So those are two of the aspects where I have seen very, very successful implementations
Wow, that's
so
amazing.
far.
Because typically encrypted information, if you change just a little bit the actual information, the encrypted information gets very different. So neural networks are going to need a heck of layers and neurons to start learning these patterns, I'm assuming.
Indeed, yes. And that's one of the reasons why it doesn't scale that well. You cannot use, now we're talking about Gen AI and large language models that use billions of parameters. With homomorphic encryption, probably you are constrained to thousands of parameters, which reduces the number of problems that you can tackle. But for some problems, it's a very good use case.
That's amazing. So when it comes to financial institutions, and we have already tackled that a little bit, right? But there are ethical considerations and potential biases that come with implementing AI in the financial decision-making processes, which eventually affects everybody. So how is the ways that these potential ethical issues or biases are being mitigated by financial institutions?
Yeah, so there are at least three types of biases, and this is not specific to finance, it's more general for AI broadly. The first one is the bias in the modeler, right? So who's the person who is designing the model or you deploying the algorithm? Are there biases in the way that they are defining the rules or deciding which family of models they are going to use? And you need to mitigate that through training and revision and QA and controls on the humans who are doing the work. The second one is the bias in the data, right? And that is a tricky one, because especially in the places where you're not going to have an amount of data that is vast enough, you could have, if your training data is biased by design to begin with, then obviously your model is going to be biased. And we have seen that, as I said, this goes beyond finance. We have seen this in facial recognition software and computer vision and a number of other spaces. And that is the canonical solution, is that you need to expand your data set to make sure that the data is representative. But sometimes you just can't, because there are problems that were, by design, they are a small data problem. And there's actually a very interesting application of generative AI, which has to do with generating synthetic data. So how can you start from a kernel of real data, and how can you generate additional data sets that maintain the structure and the distribution of that original data set, so that you can prevent that bias? And then the third one, which is the one that probably people talk about the least, but is highly relevant, is drift in the model. Think of, for instance, that you design random forest to do loan underwriting, and you train that on historical information on loans, who paid, who didn't pay, and you use that to make decisions to grant new loans. Over time, you will continue to train the algorithm with the new data. But obviously, you only have new data on the loans that you approved, not on the loans that you declined. So you know, of the loans that you approved, you know who paid and who didn't pay. But on the loans that you declined, you don't know who would have paid. That's a hypothetical.
Who would have paid, absolutely. Yeah. There's a survivor bias here.
Correct. So you have model drift, because you're only, by design, there is a whole set of a population that you are not looking at anymore. And that is a difficult one. That is a very difficult one to address. But those three, in my mind, are the three more relevant aspects of it. You can address some of them, as we said, with culture and training and audits. Some of that will be addressed in a regulatory way by saying, hey, Mr. Banker, you need to submit your models to the central bank, and you need to be able to explain how the decision is made.
Yeah, that makes a lot of sense. And you tell the story, right, about generative AI used to supply data, right, which is called synthetic data, to the actual prediction kind of AI. Which other use cases for generative AI are being applied in finance?
So some of those have to do, for instance, with open collaboration, right? Imagine another use of synthetic data is one of the projects that we did internally. We have now information over the years of everybody in our universe who have been sending digital currencies and crypto to different wallets.
Mm-hmm.
One of the ways that we will, but obviously that's information that is proprietary and is confidential. So one of the uses of synthetic data is that you can generate not additional data, but a data set that is not anonymized, is new data, but has a distribution that is the same of the data that you had in the past. So there is a data object that you can make available for research institutions and in general researchers to do work around without jeopardizing confidentiality of customer data, because the data was never anonymized to begin with. It's just new, brand new data. There is a broad use case around productivity, and especially engineering productivity. We were discussing about this before we started the podcast. I think that the advances of Gen AI as a co-pilot for coding activities and for engineers are fantastic. And maybe it's not that great in making an exceptional coder better, but definitely, like in my case, is really good at getting a really bad coder and making them acceptable. And in terms of, we see that in terms of debugging, in terms of time to learn new languages or no need to learn new languages or be able to transpose a code base from Python to Java. So definitely engineering productivity is one aspect that we are looking at intensely. And the other has to be more with consumer interactions, with front-facing interactions of several types. For instance, some of that has to do with your old world of chatbots and customer service, and how you can provide better answers to consumers who are reaching out. Part of that has to do, in our case, for instance, there is a lot of work that revolves around merchants trying to integrate payment instruments. And they have questions and they have technical questions, and a lot of our, if we are able to provide better information to developers in the sense that makes it more useful to interact with our products, it helps us increase our adoption. So we are also working on that way of being able to make our products easier to integrate by deploying Gen AI to make the developer's life easier on the other side.
Wow, that's amazing. That's fascinating. And listen, you're living in Silicon Valley. It's the edge of the edge of the edge of technology. So
the precipice.
Exactly, before the cliff. So now the big question that by definition nobody can answer, right? But is, how do you see the future of AI? Where do you think we are going with all these technologies?
That's a really good question. I think that we are obviously scratching the surface. There are technical implications and maybe societal implications of that thing. On the technical side, I don't know that anyone was expecting to see what we saw when ChatGPT came out last year. I think that everybody was talking about LLMs as something that was there, but it was not as practical. And now you see that it's appending internet searches, and it's totally changing the way that you interact with your computers every day. Where do we go from there? The models will get better, which is in a way scary. My concerns are on the technical side. I'm intrigued about some of the things that are happening once that you have exhausted the LLM efficiency curve, and people start already to talk about SLMs and so small language models and models that you can interact with in a smaller device. A big push toward deep learning was the ability to do federated learning. So basically having the data that happens in your small device and then being able to extract learnings and consolidate the learnings without having the massive data asset. And so, but I care a lot. I work on blockchains, so we all in this space have a little bit of a decentralized streak. I care a lot about centralization and decentralization of industries. And my concern is that we gravitate to a world that is super centralized around the companies who have the data assets. So
and the computing power as well, right?
Indeed, there are decentralized ways to get access to the computing power. Obviously, there is a scarcity of GPUs now, and that is an issue.
Yes.
But hopefully, the market will solve that over time. The supply will increase, and we already have ways, and it's a little bit of a fractal because there are decentralized ways to get access to computing power by using cloud platforms. But they are basically three. So the cloud platforms then they themselves are kind of centralized. But having ownership of your own data is something that is very important for me and in my mind. And there are, because if you think of the economics of centralization and decentralization, they mostly revolve around transaction costs. This is not engineering; it's just economics. And the reason that I work for PayPal and I have a contract with them is that the cost of negotiating between PayPal and I, the work that I was going to do every day as a freelance, would be just prohibitively expensive. So things get centralized when the transaction cost of doing something in a centralized way is lower than the transaction cost of doing it in a decentralized way.
That's correct. I love that way to looking at things.
Yeah, and in that sense, anything that we can do to reduce that transaction cost will provide that balance between centralization and decentralization that I think is healthy. One of the things that we are seeing, for instance, the data assets that are used today to build those data models are built, most of them on the basis of the evolution of Web 2.0, right? The companies that social networks, Google, search, and the like, where the client information is on the server side. There are 3 or 4 things that we got wrong with internet the first time around, right? One of them is identity, and you remember the cartoon at the New Yorker that nobody knows if you're a dog on the internet. So that's right. That's why fraud is an issue. The second one is payments. If I remember, there is still an error 404 that says payment credentials suspected. So somebody was working on it and never got to it. And the other is the client server model. So this idea that the client accesses the application, but the data resides with the application, not with the user. That's what led to the accumulation of these data assets. One of the things that I do love about blockchain technologies is how they're trying to break that. There is now a fascinating company called Farcaster. Farcaster is a protocol for social networks where you can build a social network, but the user keeps the data in control, which means that those, similar to Discord, those social networks are attached to specific servers. And if you get fed up with the manager of your server, you just pick up your data and you go to another one. And that is, that is quite fascinating. I care about regulation. I care about AGI, so about artificial general intelligence. But quite frankly, even conceptually, I don't know that we are going to get to AGI at any point in time. Or I don't know. It's not that I don't know whether we're going to get there soon or not. I am not sure that is a problem that can be solved. There are, as you know, there are some problems that just can't be solved. Is incompleteness, the incompleteness theorem of mathematics. There are problems that are unsolvable. I have some background on neuroscience, and I think that gives you a lot of humility when you know that we have no bloody idea how human intelligence works. So I don't know how we will be able to replicate that in a computer. So I wouldn't be too concerned about general intelligence. I'm much more concerned about concentration of those models in a small number of entities, whether they are nation states or companies or whatnot.
That makes a lot of sense. That's a very thoughtful reflection about the future. And I completely agree with you. Listen, I want to be respectful with your time. I know you are busy with PayPal, cryptocurrencies, AI, and all this fun stuff. I believe you have a profile in LinkedIn. So I'm going to tell my audience, I'm going to put a link to your profile if somebody wants to contact you to learn more. And I want to thank you for your time tonight. That's been amazing.
My pleasure. Thank you so much for having me.
And for the audience, very soon we're going to have another very interesting episode of the Torras AI podcast. Stay tuned.